Hello, everybody. I would like to introduce Python and how it can be used for AI. So the slides I'm going to be using today are available from the CS224n course offered by Stanford University. And also, I'm going to be using an interactive lab also built by them in order to introduce Python. So the Python language is named after Monty Python's Flying Circus, and it looks like two entwining pythons based on the Mayans' representations of the snake. So today we're going to be covering why Python is such an important language for machine learning, as well as how to set it up, the different basics and data structures, as well as a package called NumPy in Python, which is extremely critical for machine learning applications. So first, let's start with why Python is so important. So Python is an extremely widely used and general purpose language. In fact, you can see that it's 25.95% most popular in the entire world compared to other programming languages. Additionally, it is easy to learn, read, and write, as it is extremely similar to English with many different adaptations from other coding languages that allow it to be more similar to English and more intuitive. Additionally, it has computation abilities similar to more complex languages, but it is offered at a much easier to understand way. Additionally, many different deep learning frameworks such as NumPy or TensorFlow and Keras are available on Python, and it is very active with other libraries as well to support the machine learning journey, as well as other open source initiatives that improve it continuously. So Python uses a thing called an interpreter, which allows it to take the code that you write in an English similar format into something that the computer can understand. So first, it takes your high-level programming and it takes it through the interpreter in order to turn it into executable code and an output. So this is done by interpreting the Python code you write into a byte format, which is then compiled. Since Python is so similar to English, it can sometimes be slower to run. However, you can use different optimized C routines inside of Python to make operations fast. In fact, NumPy's popularity as a library in deep learning is because it is written in C, which allows it to perform much faster operations. So some of Python's basics include that it is a strongly typed language, meaning that when you define a variable in Python, that means that the type of that variable, for example, an integer number or a normal text input, the interpreter of the code will always remember that that variable is of a certain type. So for example, if you attempt to add an integer and the same integer but in a string format, then you will see an error as they are different types and they cannot be added or changed to support the operation. Additionally, adding the type of list and the type of set will also lead to an error as they are different types and they cannot be changed in order to allow this computation to be done. Additionally, Python is a dynamically typed language, meaning that a variable is only a value and a variable cannot be assigned to a specific data type. This means that once you define a variable as a specific data type, for example, as a number, it can be changed later to different data types such as lists or strings. So let me just provide a quick question and perhaps you can answer in the chat. So if we have this code where the variable x equals 5 and the variable y equals the string of 3, what will you see when you attempt to add x and y and output it in the console? I'll give you a few seconds to answer the question. All right, so it looks like we are seeing the answer C, which is indeed correct because you cannot add an integer and a string type. So good job to everybody who answered the question. Thank you. All right, so now let's see how we can set up Python on a local computer. So first, I'd like just to note that code in the future is going to be written in this font. Command line inputs are going to be prefixed with the $, and outputs are going to be prefixed with the greater than sign. so we can have a more clear understanding of what is the input, what is the output, and what is the code that caused both of these. So to install Python, we can go to the python.org website where all of the open source Python releases are available. Currently, the most used version is 3.13 as it is the most recent and has the most support. However, there are older versions and the newer pre-release version of 3.14 available. So some helpful commands on the command line in Python include finding the version of Python that you have, which could be useful when you need to determine what version of Python you have for other operations, to see where Python is located as is downloaded on your computer. You can use the $which command of Python or the $where command, depending on if you have Mac, Linux, or Windows. To see the installed libraries that you have on Python, you can use the -m pip list to see all of the installed libraries and modules that you may have. Additionally, you can run Python scripts in different modes. So by using the $Python, you run an entire Python script which is defined in a code file with the ending .py to have it in interactive mode, which means that each line is printed and you can run each line separately. You can use the -i prefix so it has that interactive mode. Additionally, you can use the -c command in order to have one singular line that you write in the command line run inside the console. So to manage all of the Python environments that you may have, as sometimes, especially if you are on a Mac, there can be different versions of Python with many different Python packages as well as the packages they need to work, and even sometimes different versions of those packages inside of each project you may have. To solve this, we have a system called virtual environments, which isolates different Python environments from each other, where each environment can use its own Python version with its own packages, and these environments can be extremely easily replicated, which is why they are so widely used. So the first way to do this is through an environment called a venv, which is built on the base Python and can be used with different commands in the command line, as well as in integrated developmenting environments, which allow you to create new virtual environments, venvs for each project, where each version of Python and all its packages are separated so they do not get confused between your different projects. The second way is through a software called Anaconda, which is called so as when you think of an anaconda, it circles each project and keeps it isolated from the rest of your other projects. It is very popular as it is easy to use and it is supported on many different types of software as well as many different versions of Python. To install packages in a Conda environment, there are many different commands that you can also see by searching for Anaconda documentation, but here I'll give a simple example of installing the pip package, which is used to install all other packages by using conda install -n myenv pip. Additionally, you can activate your environment that you create by using the activate command, and then you can use pip install to install any packages that you may need. So the third solution to this problem are IDEs, which are integrated developmenting environments, which are used on different text editors. So the main two that I recommend are PyCharm and Visual Studio Code, as those are the ones that I have expertise with. However, you may be able to find others, such as the built-in text editors, such as TextEdit on Mac, or you can also just run your own Python codes that you write in the terminal by using python filename.py for any Python file you may have. So the fourth solution to this problem of managing different environments in Python are Python notebooks, which use the type .ipynb in order to have a block-by-block code that can be used to run many different parts of the Python code individually. So the first way to do this is through Jupyter Notebook, which executes the Python notebook in your web browser locally, and it can use your own system's resources. However, if you don't have a computationally intensive computer, you can also use Google Colab, which hosts Jupyter Notebooks in the cloud offered by Google, which allows you to run different Python notebooks with extremely powerful GPUs for absolutely free. We will actually be using Google Colab for the labs in this course, and we will be able to do this because Google offers it for free, and we have access to GPUs that are extremely important for the future labs we will be doing, where we need to train artificial intelligence models like neural networks that need extreme computational resources. So now I'd like to have a matching activity. So we have the terms venv, Anaconda, Jupyter Notebook, and pip. We have the terms A, B, C, and D. So in the chat, I would like everybody to answer the different matchings between 1 through 4 and A through B. So if you'd like to do this, you can put, for example, 1-A, 2-B, etc. for whatever answer you reach. So I'll give everybody a second to do that. So if anybody would like some hints, so the pip is a package, and it is separate from venv, Anaconda, and Jupyter Notebook, which are all used for managing of Python environments. And Jupyter Notebook is hosted in your web browser rather than completely locally. So if that helps anybody, please feel free to answer in the chat if you have any answers. So I'm seeing that we have the matching from 4 to A, 1 to B, so venv to B, Anaconda to D, and Jupyter Notebook to C. So now I think that everybody is answered. Let's see the answers. So 1 was B, because venv is a tool for creating different isolated Python environments. 2 is C, as it does have the simplification of managing your packages and environments. With Jupyter Notebook, 3 is D, because Jupyter Notebooks are interactive and they run code with different visualizations. Finally, pip is indeed the Python package manager that you can use to install and manage libraries. So for everybody who answered the question, thank you so much and congratulations. Now I'd like to get into some of the Python basics that are critical for writing code.
Not everybody got that right. Do you want to address?
Oh, I'm sorry.
Most
Okay.
people said 2D and 3C, while you said it was 2C, 3D.
All right.
Is there a reason why people got that wrong or understood the difference?
Okay, I understand. So Anaconda is the way to manage your different packages. So that's why it is the answer C. And I understand why it may be complicated, as it is extremely difficult to sometimes understand all the different ways you can manage your packages. But with Anaconda, it is actually designed for data science because it was created by different data scientists, and they wanted to have Python separations for different versions and packages. So it's very similar to venv, in fact. However, venv is more built into Python, while as Anaconda is more of a third-party software. And Jupyter Notebooks are interactive because, as I said, they allow you to have each block of code run one by one, and you can have different visualizations and notes outputted next to each block in the console. So does that clear everything up?
It seems only 2 and 3 were swapped, but
Yes.
1 and 4 were.
Yes. All right. Okay. So now with the Python basics, so I'd like to go through the different ways that you can define things in Python, as well as operations you can use to have Python work in your favor. So to declare a variable, we use the variable name equal to the value that you want to set it to. So we're going to define two variables equal to integers, so x equal to 10 and y equal to 3. You could see on the side here that comments are starting with the hashtag icon, which is useful when you want to add a comment to each line of your code and you want to remember what each line of code does. So now that we have our variables x and y, we can have different arithmetic operations. So for example, if we want to add these integers, we can use the plus sign, similar to how you would do it in math. So 10 plus 3 is 13. If you want to put different numbers to a power, we can use the double asterisk sign. So if we have x to the power of y, that means we have 10 to the power of 3. Since 10 times 10 times 10 is 1000, that is indeed what we see outputted. To divide two integers with rounding, we can use the backslash sign. So if we divide 10 by 3 with this backslash, we get 3 as it is rounded to the nearest integer. However, if we want to have a floating point number that has the more exact representation, we can convert our variable y to a float by using the float parentheses y syntax, which allows us to have 10 divided by the floating point number 3, which leads to 3.333 repeating, etc. If we want to change our integer variables into strings, we can use the str parentheses, the variable syntax. So if we turn our variable x to a string and add it to the string plus sign, as well as turn our variable y into a string, we will see 10 plus 3 is outputted, because 10, the string of 10, plus the plus sign, plus the string of 3, has our string outputted as 10 plus 3. So there are also some built-in values into Python that can be useful sometimes when you don't want to have your own declarations. So the true and false values are, as you expect, to set a variable to true or false, a binary value. And we can also have a variable called none that represents the absence of an assignment. So if we set a variable to none, it can be x equals none, meaning that x is just defined, but it is not equal to anything at this moment. We can also have lists that contain the variable none. So if we have an array equal to the integers 1 and 2, as well as none, this code will work fine without any errors. Additionally, we can define functions using the syntax def, the name of the function, parentheses. If we have any inputs, we can put them in those parentheses there, a colon, and an enter with indentation for all of the lines inside of the function, as well as the return statement to return the value of none. Additionally, to have operations on Python, we can use the plain English operators of and, or not, instead of operations like and, the bar, or exclamation signs as used in other languages. This makes Python very simple to understand, as if you have two Boolean values, x and y, we can check if both of them are true, if one of them is true, or if one of them is inversed. So if we use and, we check if both values are true that we're comparing. If we use or, we can check if one of the values we're comparing is true. And if we use the not, then we sort of inverse whatever value we have with the not. So if we have a true value, not true is false, and not false is true. So to compare two different values, we can use the equals equals or exclamation equals to check for equality or inequality. So we can define an if statement by using the keyword if. If an empty list is not equal to a list containing none, the colon, as we did with the function, and then indentation to signify anything inside of that if statement, where we will print in the console the statement not equal. So this if statement is comparing an empty list to a list containing the value none, and if those values are not equal, then we will have an output of not equal. However, if they are equal, then we will see no output. So the indentations in Python are used to signify what blocks of code are under other blocks of code. So these are used in functions, if statements, and loops. So if we want to define the function sign to see what sign a given input of num will have, we can have the def sign of num colon operator, and then indent all of the code inside of our function with 2 or 4 spaces, but it should be consistent throughout the code file that you have. Then inside of that indentation, we can have embedded if statements with their own indentations to show which parts are inside of each if statement. So if we want to see if our number is equal to 0, we can use if num is equal to 0. And if so, then we will print in the console the word 0. We can use the elif statement to chain onto this if statement and check for other conditions. So if our number is greater than 0, then we output positive, and otherwise, which means our number will have to be less than 0, we can print negative and output the word negative. So now I have this block of code here, and I would like everybody to point out the errors that are inside this code. So I don't really want you to write this entire code as it is quite long, but if there are any errors, I would like everybody to point out at least one error that you may see throughout this code. So I'll give everybody a couple seconds to do that.
You also have the ability to unmute and talk.
Yes, also that. So let me actually turn on everybody's available cameras. So you can use the raise hand button inside of Zoom, so I can call on you to raise your hand, and I can ask you for anything that you see wrong with this code. I'm sorry, could you please say that again? Yes, Miss Tran, go ahead.
I see the if condition lack of the colon.
Okay,
But
yes, that is
ending.
one. Yes, it should have a colon there. Any other errors anybody could see? For a hint, you should, in Python, you should usually define your variables to start with a letter from A to Z, and then inside of the variable name, there should be no spaces inside of your variable declaration. So the entire variable name should be one word, not starting with any numbers, then equal to whatever value you would like to set it to, just as a hint.
They're in the chat. Mentioned.
Okay.
0 length equal to 10, that is error, right?
Yes, correct. So the 0 length should not be starting with a 0. It should be just the value of length. Additionally, I also see in the chat that somebody pointed out the mismatch between the string declaration. So it has a double quotation and then a single quotation. So that is also another issue. And also the print
And
statement.
area equals to 0 length into width. That is also
Yes, that should also change. So when the variable declaration changes, everything else throughout the code that uses it should also change. So that 0 length should become length in the variable declaration, as well as in the area variable declaration that has the length variable in it. I also noticed. Yes, go ahead. Go ahead. Yeah. Oh, okay. So the print statement should be having, in this beginning work print statement, there should be the parentheses around it. As we can see in the second print statement that is here, it has parentheses around it, so that should also be in that print statement. I see that in the chat. And the float width should also have no space in between it. It should be changed to the float width as one word, and then also this declaration down here inside the area variable. So the variable of width should change to float width as one word. So now, if we look at the solution, we can see that the variable declaration cannot start with a number. We should not have the space between these two names in the variable. It should be float width as one word. There should be parentheses around the print statement. And also, here in this width declaration, there should be one word as float width. That should change, as well as the 0 length should change to length here as well. In the if statement, there should be a colon after this declaration. And also, one complex error is that this area variable is equal to an integer or a floating point number, and before adding it to the string to print, it should be converted to a string value, so that way the plus operation is not working between a string and a floating point number. It should be a string to a string. Additionally, finally, the mismatch between the double quote and the single quote in the final line should also be fixed to either be both single quotes or both double quotes. Both are supported. So those are all the errors in this code that we have. So everything is fixed now. Good job. Now, I would like to talk about some of the different data structures that are inside of Python. So first, the type of lists, which are a type of data in Python that contain different items of the different types that we've covered, such as integers, floating point numbers, or strings. So we can define a list of names containing the names Zach and Jay with the syntax of a square bracket and comma and a space separating each of the names inside of our list. We can access the first name in our list by using a method called indexing, where each item in our list is set to a specific index. So the first item is 0, the second item is at index 1, and if we add more items, it would continue in that fashion. So if we access the name at index 0 using the square bracket 0 close square bracket for our list of names, we get the output of Zach. And if we want to add a name to our list, we can use the .append method with the new item we want to add. So if we want to add the name Richard to our list, we can use names.append the name Richard. Then we can use the len method in order to determine the length of our list. So since we now have the names Zach, Jay, and Richard, if we get the length of our list of names by using len, open parentheses, names, close parentheses, we will get the output of 3. We can also print our list of names using the print statement, which we see is Zach, Jay, and Richard, which are 3 names. So if we want to add 2 lists together, we can use the plus equals operator, which is pretty much just shorthand for our original list of names equal to that list of names plus a new list that we want to add. So we can use names plus equals the 2 names in the list Abby and Kevin. And if we print our final list, we can see it has Zach, Jay, Richard, Abby, and Kevin, 5 names. So some other examples working with lists include the 2 ways to define an empty list. So first, it is with empty square brackets, and second, it is with the list parentheses constructor. So both of these will create an empty list in the same fashion. However, the first way is if you want to quickly create a list, whereas the second is if you want to remember that the variable you are defining is of the type list. Additionally, one thing unique about Python is that lists can contain different types inside of them without any errors. So if we have a list of stuff containing the integer 1, the inner list of the strings hi and bye, a floating point number of negative 0.12, and the value of none, we can see that there will be no errors caused by this code, as Python has support for different data types. So another way to manipulate lists is using the method called list slicing, which accesses specific elements or parts of a list. So usually this is formatted as the name of your list, open square brackets, the start index, colon to the end index, close square brackets. So the starting index is included whenever you have this slicing operation, while the ending index is not included. So let's define a list of numbers equal to all of the integers from 0 to 6. So 0, 1, 2, 3, 4, 5, and 6. Then, if we want to slice this list from the index 0 to the index 3, the index 3 will not be included, so that means we will have 0 at index 0, 1 at index 1, and 2 at index 2, and we can see that this ends up with the output 0, 1, and 2. This slicing operation of 0 to 3 is also equivalent to having colon 3, as when you don't define a starting index in a list slicing operation, it is assumed to be the start of the list, which is always 0. Additionally, when you don't define a ending index, it is assumed to be the end of the list. And as that list ending index is not inclusive, it will be assumed to be 7 in our case, as we have 7 items, and that 7th index is not included. So this is at index 6, and index 7 is not defined, but is not included in our slicing operation. So the last item that will be carried is 6. So if we slice from 5 till the end of the list, it is equivalent to the operation of 5 to 7, which is the integers 5 and 6 at index 5 and index 6. Additionally, if we want to take a copy in memory of the entire list, we cannot define a start or end index, and we just have a colon. This creates the entire list of numbers from 0 to 6, again, with a copy in memory, which will be useful later when we are working with the interactive Google Colab lab that we need to have a list copied to be worked with the copy in preserving the original list. Another thing that is unique about Python is that we can use negative indices to start counting from the back of our list. So if we want to access the element at index -1, that will be our number 6, as that is the last number in our list, and it is at index -1, as we're starting counting from the back of the list from right to left. We can also use these negative indices in a similar fashion with slicing operations. So if we slice from the -3rd index, which is, so this is index -1, -2, -3, so we'll be slicing from 4 all the way till the end of the list. And here we have 4, 5, and 6. Additionally, if we want to slice from the index 3 to -2, we can have the number 3, which is at index 3, and then the -2 index is at 5, and since that index is not included, we will see the numbers 3 and 4 outputted, as that -2 index is not included, so it is from the 3rd index to the 3rd last index, 3 and 4. So now I'd like to cover the second data type in Python called tuples, which are extremely similar to lists, but unlike them, they cannot be changed. This means that we cannot add elements, remove elements, or slice tuples. So we can define a tuple with extremely similar syntax to the previous lists with, instead of the square brackets, we use parentheses. So we can use similar operations such as the indexing or finding the length of our tuple, which lead to the same output. So if we get the item at index 0 in our tuple, we get the name Zach. And if we find the length of our current tuple, since we have two names, Zach and Jay, we get the output of 2. Additionally, we can still print our list of names, as that is not changing the list. However, if we attempt to change our tuple by changing the item at index 0, Zach, to the name Richard, we will receive a type error that states tuple object does not support item assignment. This means that we cannot change our tuple after it is defined. Now I'd also like to introduce the second way to define an empty tuple, which is with the tuple parentheses operator, which creates the same kind of tuple as the empty parentheses, and also the specific special syntax used for a single element tuple, where you have to add a comma after the first entry, because we want to make sure that this single tuple has the type of tuple, so we have to make sure that it is having that comma at the end of the first item. So the third data type that I would like to cover are dictionaries, which are mappings between different keys and values. So to define an empty dictionary, we can use a pair of empty curly brackets or the dict parentheses operator, which is similar to the list and tuple operators, in that if you want to create a quick dictionary, you use the curly brackets, whereas if you want to remember that is type of dict, then you use the dict parentheses constructor. So you define a dictionary with one item, we can use the syntax of the key, colon space, the value. So if we want to create a phone book dictionary, we can have the string Zach, colon space, his phone number of 12-37. To add a second entry, into our dictionary, then we can use a syntax of phone book, open square brackets, J, close square brackets, is equal to the value of 34-23. This creates a mapping between a key of J and a phone number value of 34-23. So you see that the dictionary has string-to-string mappings. However, dictionaries can have many other types besides the strings and also support different types of keys and values inside of individual dictionaries. To check if a specific key is in our dictionary, we can use the key in dictionary syntax. So if we want to check if the key Zach is in our phone book, we can use Zach in phone book. We can use the similar syntax for the name Kevin, Kevin in phone book. We see the value of true outputted for Zach in phone book, as Zach is our first entry, whereas for Kevin, we have false, as Kevin is not in our dictionary. To get the corresponding value for a given item in our dictionary, we can use the similar syntax to defining a key value pair, but instead of defining a value equal to a key, we just use the key accessing part, which is the phone book, open square brackets, J, close square brackets. This returns the value of 34-23, as this is the corresponding value for our key. To delete an item, we can use the del keyword along with the given key for the key value pair we want to delete. So if we want to delete Zach and his phone number, we can use del phone book Zach, which will leave us with the final phone book of J and the phone number 34-23, the only key value pair. So another method in Python are loops, which are used to iterate over different data types. The two different types of loops are for loops and while loops. And today I would like to cover the for loop. So if we want to define a for loop that prints all integers from the range of 0 to 10 with the number 10 being excluded, we can use for I in range of 10, colon, indentation, print I. So for each index I in the range from 0 to 10, with 10 being excluded, we will see the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. To iterate over a list, let's first define a toy list of names equal to Zach, Jay, and Richard. If we want to print each of the names in our list, we can use for name and names with similar syntax to the previous for loop we defined. So if we print hi to the name that we are currently on with an exclamation mark, we will have hi Zach, hi Jay, and hi Richard for each name in our list printed independently of each other. To iterate over indices and values, we can use two different ways. First, we can use the range of the length of our list of names and then iterate over that with the indices and their respective entries. So we can have for I in the range of our length of our list of names, and then print the index with its associated name inside of our list. So when we do this, we should get 0, Zach, 1, Jay, and 2, Richard. So this 1, 2, 3 should actually be 0, 1, and 2. Another way to achieve this output is to have the enumerate method, which now assigns an index and a name to each value in our list. So we have new syntax of for I, comma space name in the enumeration of our list of names. Now we can just print the index and its associated name to get the same output of 0 Zach, 1 Jay, and 2 Richard. To iterate over a dictionary, there are several different ways to iterate over the keys, the values, and the key value pairs. To iterate over the keys, we can use similar syntax to the list looping by having for name in the phone book and then printing each name. So if we have a phone book with the names Zach and Jay with corresponding phone numbers 12-37 and 34-23, we will get the keys Zach and Jay outputted. Then, if we want to access all of the values in our dictionary, we can use the for number in phonebook dot values and then print out each phone number. This will give us 12-37 and 34-23. If we want to iterate over both keys and values in our dictionary, we can use the for name dash, comma, space, number in phonebook dot items. Then we can print each name and the number, so we get Zach 12-37 and J 34-23. All right, now I would like to have an activity where we're going to use a combination of everything we've learned, including lists, dictionaries, slicing, and for loops to see what the output of this code is going to be. So we have a first list containing the names Eeyore, Goofy, Nemo, and Wally, and we have the dictionary containing the names of some of these characters as well as their ages. So Eeyore, 12, Nemo is 2, and Goofy is 42. We're going to slice our first list between the index of 1 and -1, and then we will loop through each name and get its corresponding value in our dictionary. So I'm going to give everybody a second to perform this activity and see what the output is going to be. You can answer in the chat, or if you would like, you can also speak out loud what you believe the answer may be.
Hello.
Yes?
Yes, Rahul. The answer in the loop is first print will be one is every 1 year old.
I'm sorry, but could you please repeat that louder?
One is a year old.
Uh, okay, I think let me just go through this one. So we're going to slice our list, and we are going to have from 1 to -1. So our first slicing is going to be at index 1, which is Goofy, and then at -1 is going to be Wally. So since Wally is not going to be included, 1 to -1 with -1 being excluded will be Goofy and Nemo. Then if we get Goofy and Nemo's ages inside of our dictionary, Nemo is going to be age 2 and Goofy is going to be age 42. So when we run this code, we're going to see the output that Goofy is 42 years old and Nemo is 2 years old. So are there any questions about that?
No, thank you.
All right. So now I'd like to go into the library of NumPy, which is extremely critical in machine learning and especially deep learning. So first, I'd like to give an introduction to how you import NumPy, as it is not actually a built-in package into Python and it has to be imported. So to import a module as it is, you use the import keyword as well as all of the modules you want to input. So if we want to, for example, input the OS and time modules, we can use import OS, comma, space, time. If we want to import a library under a shorter name, we can use the import library name as shorter name format. So if we want to import NumPy as NP, we use import NumPy as NP. And to access any functions inside of our library, we can use np dot and whatever you would like to use. So in this case, we're performing the dot on a given variable of x and y. There are many other operations inside of NumPy that you can perform, and the syntax will always be np dot whatever you would like. So to import specific submodules or functions from NumPy, you can use the from NumPy import a given submodule. So for example, if we want to have linalg, we can import it as LA, and we can also import the dot submodule as matrix underscore multiply. So that's how you import different packages under shorter names as well as specific parts of packages. So NumPy as a package is optimized for different computations on arrays as well as multi-dimensional arrays. It uses C and C++ backends in order to have memory-efficient operations as well as data structures. And the main data type is the ND array. So to create one, you can use the np.array syntax, where you can define a array of any dimension. But before we move on, I would like to identify two critical terms called vectors and matrices. Vectors are one-dimensional arrays, and they can be defined in NumPy with the np.array syntax and the same square bracket definition as a normal Python list. Matrices have 2 dimensions or more, and they can be defined with multiple nested square brackets in order to have multiple columns, rows, and other dimensions as well. NumPy is especially useful for machine learning as its operations are 5 to 100 times faster than standard lists built into Python. So the NumPy arrays, let's define 3 first NumPy arrays to play around with. So first, the first NumPy array will be a one-dimensional array containing the entries 1, 2, and 3. The second will be a two-dimensional array containing a one-dimensional 3, 4, and 5. Then the third NumPy array will be a 2 by 2 with the rows 6, 7, and 8, 9. When we print all of these, we can see they are formatted with the first NumPy array being similar to a normal array, the second NumPy array also being similar to a normal array, but with a second layer of square brackets as it is two-dimensional, and the third NumPy array having a format of 2 rows and 2 columns with another nested square brackets on the outside to show that it is two-dimensional. We can use the .shape command to find the shape of these arrays, which is defined as a tuple. So the shape of our first array is of shape 3 as it is one-dimensional. The shape of our second vector is 1 by 3 as it is two-dimensional but still only contains a one-dimensional input. And our third array is 2 by 2 as it has 2 rows and 2 columns. So shapes in NumPy are actually defined with the rows by the columns, which will be extremely important later when we are looking at different NumPy arrays in the future. Note that vectors in NumPy can be of shape n, 1 by n, or n by 1, and all of those shapes are vectors, so our first 2 NumPy arrays are vectors. However, all of these shapes are not the same, and although they are all still vectors, they each have their own different properties. So to operate on different NumPy arrays, there are many different ways to manipulate them, including the .max, .min, .amax, .sum, and .mean, as well as many more operations. These are all these operations are called reductions, as they reduce a NumPy array along a given axis. So, for example, if we have a NumPy array of shape 3 by 2 with the entries 1, 2, 3, 4, 5, 6, then we can use the np.max function to find the maximum along each of its rows, as we have the axis equal to 1. If axis was equal to 0, then we would have the maximum found along each of the columns. So if we use np.max on our 3 by 2 array, we will have a one-dimensional vector outputted containing an entry for each of the maximums from each of the rows. So in the first row, 2 is greater than 1, having 2 for that row, 4 is greater than 3, leading to 4 being outputted, and 6 is greater than 5, having 6 as the final entry in our 3 by 1, our 3 shape matrix. If we want to preserve the dimensions and keep it as a two-dimensional array, we can use the keepDims equal to true argument in our np.max function to give us that second dimension back with a 3 by 1 shape. So there are also other operations that can be used element-wise that can be used between different vectors and matrices. So to find the element-wise product, where each corresponding element in a vector or matrix is multiplied, we can use the asterisk sign, and that will have a multiplication between the different entries in a matrix or two matrices, so that way each item is correspondingly multiplied. In the lab that we're going to be doing later, we will see a more concrete example of this. The second operation we can perform is called the dot product, which is usually done between two vectors to multiply corresponding entries and sum them together to achieve a final output. This is also sometimes called the matrix vector product for 1D array vectors, and it is used with the syntax np dot dot and then the two vectors or matrices you want to use. Then a matrix product or multiplication is similar to dot product, but it takes the dot product of each corresponding row and column in two different matrices, and it is done with the np.matmul or the at operator, and they are both used simultaneously to perform matrix multiplication on two matrices. Finally, the transposition of a matrix is when the rows and columns are switched in a matrix, and it can be done by having the matrix dot t to transpose its rows and columns. To index a NumPy array, it is similar to the indexing syntax as built-in Python lists, but instead it supports multiple dimensions. So if we create a 3x4 matrix with random floating point numbers, we can select all of the entries in our X matrix by using the colon operator, selecting the rows at index 0 and 2 using an inner NumPy array containing the entries 0 and 2, and all of the entries in each row with the colon operator. We can also select a part of our second row using the index 1, and then the items from index 1 to 3, with 3 being excluded, meaning that in our second row, the second and third items are chosen. Additionally, we can index a NumPy array using Boolean operations. So for example, if we want to find all of the floating point numbers that are greater than 0.5 in our matrix, we can use x is greater to 0.5 to output a vector that has one dimension containing all of the entries greater than 0.5. Additionally, if we want to turn this vector into a 3D vector, we can select all of its rows and columns and use the np.newAxis operator in order to add a third axis and turn it into a shape of 3x4x1. Now, I'd like to cover a method called broadcasting inside of NumPy, which changes the shapes of different NumPy arrays to correctly perform mathematical operations. So let's define three new NumPy arrays. The first was shape 3x4, the second was shape 3x1, and the last was shape 1x4. All of these contain random floating point numbers. Then we can use x plus y, which will add all of the corresponding entries inside of y to each column of x, 4 times for each of the 4 columns. If we want to multiply the first and third NumPy arrays element-wise, then we will multiply each of the entries in our third NumPy array by each row in the matrix for each of its 3 rows. To visualize this, let's look at the first and second NumPy arrays visually, adding them together. For example, if our first array was from 1 to 12 with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, plus the vector of 1, 2, and 3, the 1, 2, 3 addition would be sent throughout each of the rows to add 1 to everything in the first row, 2 to everything in the second row, and 3 to everything in the third row. Additionally, similarly, for the first and third NumPy arrays, the third vector is multiplied throughout each of the rows in our matrix so that each column, the first column is multiplied by 1, the second column is multiplied by 2, the third column by 3, and the fourth column by 4. This achieves a correct output without any errors. So generally, broadcasting will work by comparing the shapes of two matrices element-wise, starting with the dimensions on the right towards the left. So two dimensions will be compatible for broadcasting when they are equal or one of them is equal to 1. So if we define three new NumPy arrays with shape 3 by 4, 3 by 1, and shape 3, we can perform different operations on these NumPy arrays to see what they will give us. Right now, I just don't want you to worry about these operations, as we will cover them in more detail when we go through the lab in a couple of minutes. So quickly, I'd just like to cover that the first operation and the third operation will work, while the second operation will give us a broadcasting error, which we will go into more detail in the lab. Finally, I'd just like to cover how NumPy code is far more efficient than normal loops. And when you're working with NumPy arrays, you should usually avoid classical for loops, as they can sometimes have 10 to 1,000 times slower operations than the built-in NumPy operations. So if we want to exponentiate, if we want to square all of the entries in a given NumPy array, instead of using a nested for loop, we can simply use the built-in NumPy operations for a much faster computation. And also, if we want to have a addition of 5 to all the entries from 100 to 1000 rows in a 1000 by 1000 matrix, we can use a much simpler syntax in NumPy as well as a much faster speed. So now here's a quick question about NumPy, or two quick questions rather, where you can create two different NumPy arrays and you can see what their shapes will be as well as what they will contain. I would like to tell you that the .arange method creates a one-dimensional NumPy array from the first number provided all the way to the second number provided, with the second number being excluded. Additionally, the numpy.random.rand operation is the same as the numpy.random.random operation that we've been using to create our previous random matrices. The answers for both are in fact B, as the .arange method, as I said, has the first number provided till the last number provided, with the last number being excluded, meaning that if you only have it from 1 to 10, the number 10 will be excluded, and the NumPy array will not contain numbers from 1 to 10. If you use it from 1 to 11, on the other hand, 11 will be excluded, giving you the range from 1 to 10, all of the integers. C and D are completely out of the question, as np.array and np.linspace are not the correct operations for this current choice. So the second question, so A does seem like a reasonable answer, as the shape is 3 by 4. However, it is not random integers that are produced. On the other hand, it is random values from 0 to 1. So I understand that I actually did not clarify this before. So the np.random.rand and np.random.random both create a matrix of random floating point numbers, meaning that they are decimals that are from anywhere from 0 to 1. That's why B is the correct answer, with random values from 0 to 1. C may also seem like another answer, but the .rand and .random operations do not go into negative numbers, and identity matrix is completely out of the question. Now I'm going to go into some very practical tips that are extremely important in Python when you want to have an understanding of the language and sometimes speed some coding practices up. So first, there is a complex method called list comprehensions, which use list creation and looping to create a list in one line rather than initialize a list and then create another loop to add entries to it. Usually, it is done by having a list definition with square brackets with some function performed on every x for a given list. So rather than defining an empty list of squares and then adding the squares of every number from 1 to 9 with a for loop, we can use list comprehension to square each I from a range from 1 to 10, with 10 being excluded, in one line, with similar syntax, but now shortened and made much simpler to understand. Additionally, we can add a if statement to the end of our list comprehension if we want to add a condition onto this list. So if we want to only square the odd numbers in a range from 1 to 9, we can add a conditional if statement that if the remainder from a division of our current integer and 2 is equal to 1, then we will only square the number then to get the squares of only odd numbers. Some other convenient syntax include assigning to multiple values to different variables. So for example, if we want to assign age, name, and pets for a given person with their age and what pets they have, we can do this in one line by having age, comma space, name, comma space, pets equal to the integer 20 for age, the string joy for name, and the list with the string cat for pets. This assigns each corresponding value to each corresponding variable name, similar to how dictionaries work, but instead defining individual variables. Similarly, this can work for a tuple, where if you have x, y, and z, each value in the tuple will be assigned to x, y, and z respectively. To return multiple items from a function, we can use this unpacking and assignment operation, so that way we can return two different values and have each value returned assigned to different values. So for example, if we want to return the integers 10 and 1, then we can assign 10 to the variable 10 and then 1 to the variable 1 for the given function we may have. With string variables, we can have the single quotes or double quotes to define a string, and then depending on the kind of string that the kind of quotations that you use on the outside, it can change the quotations you are able to use on the inside. If you define the entire string with single quotes, then you can use double quotes inside of your string, whereas if you do the opposite and define your string with double quotes, then you can only use single quotes inside. To join a list of strings, you can use the .join method for a given list based on a given delimiter. So the delimiter is what each item in the list will be separated with. If we want to join a list of the integers 1, 2, and 3 with the comma space, we can use the string of comma space dot join for our list of 1, 2, and 3. This will output a string with the numbers 1, 2, and 3 each separated by a comma and a space. Finally, you can have a single line if statement to return a given value to a variable similar to list comprehension. So if we want to have a result equal to even or odd, depending on if a number is actually even or odd, then we can have even if the operation of division between a given number and 2 is equal to 0, or the remainder of it is equal to 0, and otherwise it would be equal to odd. So some other debugging tips are the Python interactive shell, where you can execute given code that you may have line by line. This would allow you to have a deeper understanding of why you may be encountering errors. So, for example, if we want to debug a matrix, element-wise product or a matrix multiplication, we can first import NumPy, define two NumPy arrays, each 2 by 2, the first with entries 1, 2, 3, 4, and the second with 3, 3, 3, 3. We can perform the element-wise product to multiply 1 by 3, which is 3, 2 by 3, which is 6, 3 by 3, which is 9, and 4 by 3, which is 12. Additionally, we can do matrix multiplication on these two arrays to multiply each row by its corresponding column. So we can multiply the row 1, 2 by the column 3, 3. So that way 1 times 3 is 3, and 2 times 3 is 6. So 3 plus 6 is 9. This is done for the first row and second column as well, having the first row of our matrix multiplication be 9, 9. Then with the second row of 3, 3, 3, and 4, multiplied by the first column of our second matrix, 3, 3. 3 times 3 is 9, and 4 times 3 is 12, and 9 plus 12 is 21. This is done for the second row and second column as well, leading to the second row being 21, 21. Some other commands in the interactive shell include Control D to exit your current session, Control C to interrupt a current command that you are running, or Control I to clear the terminal screen. On a Mac, this would be done with Command, and on a Windows computer, this would be done with Control. Some other debugging tools include using the dot shape operator on a NumPy array to get its dimensional shape, the .d type on built-in types as well as NumPy arrays to check the data type of a given variable you may have to understand if that data type mismatch may be causing an error. You can also use the type parentheses for a variable if you want to do the same. And you can also embed variable values into a print statement by using a special type of string called f strings. So if you want to have a variable name and then print a dynamic string with that name embedded into it, you can use the f string with my name is curly brackets name close curly brackets in order to print a dynamic string for whatever name value you set it to. Much more debugging tools can also be found at this link here on the Python documentation. So some common errors that you may encounter are value errors, which are usually caused by mismatching between dimensions in broadcasting or matrix multiplication for different NumPy arrays. Usually, the first step is to have the shape of these arrays as well as the output to see why you may not be achieving the output you expect. And if that doesn't work, you can also refer to the extremely active open source community on forums such as Git Stack Overflow or GitHub, as it is likely that others have encountered your same error. So some other great references include the official documentation for the most recent version of Python at docs.python.org, the official Anaconda user guide at the Anaconda docs if you want to use Anaconda to manage your Python versions and packages, the NumPy documentation at numpy.org/doc/stable, the Python tutorial from another Stanford course called CS224n that can be found on GitHub at this link, and finally, the Stanford Python course as a whole at CS41, which can be found at stanfordpython.com.